Okay, we left off with the practice 1 problems. Now let's move on to the practice 2 problems. So for practice 2, it starts with solid calcium carbonate. So calcium is Ca. Remember, calcium is a +2 ion. Carbonate is CO3. It's a -2. So it looks like these balance out. Charges balance out here. So CaCO3 can decompose. So when things are decomposing, we're just going to get that arrow there. It's breaking apart to form solid calcium oxide. So calcium oxide is O, +2 -2. So it looks like CaO is what we got there. And then carbon dioxide gas, so plus CO2. Now this problem, again, at this point of the year, I'd kind of like you to know that carbon dioxide is a gas, but if you didn't, I told you that information. So here's our gas. Now let's make sure it's balanced. 1 calcium, 1 calcium, 1 carbon, 1 carbon, 1, 2, 3 oxygens, 1, 2, 3 oxygens. So it looks like we do have 1:1:1 ratio here. And I'm going to go ahead and circle this. Here's my gas. Here's what I'm going to focus on for gas stoich problems. Okay, for the first problem here, I'll probably need to move to the right for more room. You might want to be doing this problem in your journal instead of on this page. But it says we have 5 grams of calcium carbonate decomposing at 0.97 atm in a container at 22 degrees Celsius. What would be the volume of this gas? So again, this problem is asking for volume. That means we're going to do the stoich first. So let's set up. I have 5 grams of calcium carbonate decomposing, and we need to find moles of gas. Now the gas is my CO2. 2-step problem, grams to moles. Calcium carbonate is 100.09 grams per 1 mole. And it looks like we had 1 mole of calcium carbonate for every 1 mole of carbon dioxide produced. We do the 5 divided by 100, and we get 0.0500 moles of carbon dioxide. Now again, that is N. We're always looking for moles of gas. Okay, now that we have N, we can set it up and do PivNerd. So for this problem, it said we had 0.97 atms of pressure. We're looking for volume this time. We're trying to find the size of that container that would cause this pressure. We have N now. We can plug in that 0.0500 moles. Now this time we need to be careful with our R value. We need to make sure it matches this pressure value. So since we're in ATM here, we're going to use 0.0821 because that is the R value that has ATM in it over moles Kelvin. And I'm going to look over here at my 22 degrees Celsius plus 273. Have to use Kelvin. Okay, so we have all our variables set, so it looks like volume would equal this 0.05 times 0.0821 times 295 and then divided by 0.97, and we get 1.2 liters as our answer. Let's try another one of these. If 25 milliliters of carbon dioxide is produced at 0.85 atm and 22 degrees Celsius, now notice we're given a volume, a pressure, and a temperature. When we have all 3 of these, we're going to use PivNerd first, and we're going to do gas stoich second. So for this problem, it's asking for a mass of calcium carbonate that decomposed. Let's do PivNerd first, though, to solve for moles of gas. And then we can use moles of gas to do some stoichiometry. So the pressure is 0.85 atm. Now, during PivNerd, we have to make sure our volumes are in liters, because the R values are always in liters. So we need to look at this 25 milliliters and go 1, 2, 3. 25 milliliters is 0.025 liters. I think this would be a common mistake to make in this question, one we just need to be careful with. Now we're solving for N. Again, since our pressure unit is in ATM or atmospheres, we're going to multiply by 0.0821. And then 22 plus 273, we get 295 Kelvin as our temperature. So we solve for N this time, and we get 0.0 0.0088 moles. You're like, whoa, this is a tiny moles. Yeah, sometimes we may not have a lot of moles. It's a possibility. Okay, now we have N. Now let's say that if we have 0.00088 moles of gas, and let's think again, what is the gas? This must be moles of carbon dioxide, because that is the gas in this problem. And it was asking for the massive calcium carbonate that decomposed. So let's go to grams of calcium carbonate. Moles to grams looks like a two-step problem. First step, let's get the mole ratios. For every 1 mole of CO2 produced, we decomposed 1 mole of calcium carbonate. And now to go from moles of calcium carbonate to grams of calcium carbonate, we're going to use the periodic table. 1 mole of calcium carbonate, again, was 100.09 grams of calcium carbonate. So we multiply the numerators, divide by 1s if you really, really want to, and we get 0.088 grams of calcium carbonate is our answer. Let's check out one more of these. What volume of carbon dioxide? So we're solving for volume. So if we were doing gas stoic, we would do the gas stoic first, since we're solving for volume. Could be produced from 1.25 grams of calcium carbonate at, whoa, STP. This person's pointing, hey, check this. Maybe he's holding a stick because the arm was too long there. Hey, it says STP, ding, ding, ding. When you see STP, we're going to be thinking of 1 mole of gas is equal to 22.4 liters. If you remember this, you're going to save yourself some time. Now, we could do the old way, and we could do gas stoic to find moles of gas, and then we could plug it in PivNert, and remember that standard temperature is 273 Kelvin, and standard pressure is 1 atm, and we could use PivNert to solve this. But I want to do the shortcut. 1.25 grams of calcium carbonate, and I'm looking for volume of CO2. So let's go to liters of CO2. Calcium carbonate is 100.09 grams per mole. We need to go to moles of gas, so that'd be the CO2. So 1 mole of calcium carbonate produces 1 mole of CO2. And now here's the shortcut. 1 mole of any gas at standard temperature and pressure, or STP, is equal to 22.4 liters. So I can say 1 mole of CO2 gas is equal to 22.4 liters. And we don't have to do PivNert here because we remembered this STP conversion. Okay, now again, you multiply the information on top, you divide by the information on bottom, and we get 0.280 liters of CO2 at STP. Okay, I hope this also helped practice the gas stoic. Just remember our equations are balanced. Make sure volumes are in liters, make sure temperatures are always in Kelvin, and be careful with your units.